Greetings, the Astro 30 here, and I've got another amplifier module here to test. This little amplifier module comes pre-assembled. It's a Chinese thing, as most of them are. It's 2.1 amplifier, so it has a subwoofer output on it, plus a left and a right, and it's using two TPA3116D2 Class D amplifier modules to do it, and they're stereo modules. And the subwoofer is using one of those modules in bridge configuration to produce 100 watt, because they normally output 50 watts per channel. So by bridging it, it gives you 100 watt. But that limits the impedance you can actually load the amplifier with. So you'd really want, well, an 8 ohm sub, to be honest, because that 8 ohm sub will look like a 4 ohm load to each amplifier. It runs on a wide supply voltage range of 12 to 24 volt DC, 24 volt DC being the max, and it comes with some nice looking knobs here. So what I'm going to do is I'm going to open the package. This only cost me about 11 bucks or something. It wasn't that expensive. So we take the module and the loose components out of the bag. Now that's a knob. This is one of the knobs here. Fairly interesting. Well, interestingly made anyway. They're better than the cheaper knobs that I've seen. But let's make sure there's no metal. Now that heatsink is at a odd angle, but that's alright. I'm going to take that heatsink off anyway, and we're going to have a look at the chips underneath. They just look like surface mount chips to me. Here's the input section here, where you can have a fly lead for the input, or you can have a 3.5mm phones plugged there to a stereo one, to get your input signal in, so they can come off, say, a music player, iPod, whatever. Got your DC input over here. There's I think that's a 2.5mm center 5mm DC jack and a terminal header. We can immediately tell it's Class D because of all these coil filters networks on their outputs. Now the outputs are written in Chinese, but they do have the plus minus symbols, but I'm not sure which one's which because it's Chinese. And that's also the same for these pots, but in the order this goes, this is the channel volume or the stereo volume, this is the sub-bass volume, and this is the overall volume of the output. So basically we've got two separate controls on the input here to adjust the level of the sound, rather than just having one pot for the sub and a master. So we've got a volume control for the normal stereo channels, one for the sub bass, plus a master volume control. So I now need to look up what output is what. Okay, that was very simple. It's on the screen over in the background over there. This is the right hand channel output, which would seem strange considering it's on the left of the board, but anyway. That's the right hand channel output, that's the left channel output, and that is the subwoofer output. So now what I'm going to do is I'm going to take this little heatsink off, and we're going to have a look underneath it. They're fairly small, as most SMD is, but we can see there is an area for contacting a heatsink, so really there should be a little blob of thermal transfer compound on there between that and the main heatsink, which is what I am going to do before I power it up. So that's the assembly of the amplifier module done. So all I need to do now is get power to it, hook it up to an oscilloscope on each of these outputs and see what we get, as well as hook up an input. So yeah, we'll do that. I might just put these controls all around about halfway so we've got some form of output. So I need to find a solution for this. I don't have a cable for that, so I'll have to use a 3.5mm. I use a 3.5mm to 6.5mm phone connection, phono jack plug. Yeah, so I need to get some standoffs in these holes, so I mean fly lead connections to connect jumper leads to, so I'll just use all these offcuts of resistors and crap that I've collected over the last couple of weeks. And there's all the standoffs put in, there's all the fly leads put in. I keep calling them standoffs, that's not what they are. Anyhow, that's beside the point. So this module is now ready to be hooked up to some test instruments and power supply, etc. Ready for testing. Positives on this side of the terminal here for the power, and positive is on the right hand side of each of these connectors. Is that correct? No, that's the negative. Positive's also on the left hand side of each of these connectors for the outputs. Now, pop you on the floor and get testing. Okay, so I've got everything set up apart from the DDS yet, but I've got the power supply set to roughly 24 volt, the maximum the board should handle. I've got the oscilloscope into an 8 ohm dummy load across the right channel output, this one here, and what are we on? 1 volt per division currently. So without any input signal connected, I'm just going to turn the load on and see what happens. Precisely nothing. There is yeah, well, I did the one thing that I should not have done. I've connected the power supply up to it backwards. The positive's there, the negative's there. Okay, now, because I can see there's a large diode here next to the power connector, that is a good assumption that it does have a at least wrong way protection diode there. Now the light lights, so nothing went off with a bang, and there is no output on the scope that I can see. Alright, so now I've got the right input channel hooked up to the DDS via this 3.5 to RCA connector. 1 kilohertz 1 volt on the output. Turn the thing on, and well, I can't actually see any output at all, but I did feel that these are getting pretty hot, these coils here, but we're not outputting any signal. So just make sure that these aren't wired around the wrong way. There we go. So that's obviously the left output, not the right, according to this is the left connection terminal. The output is reasonable. That's with the total volume full, and if I put the main channel volume up full, we can see it's reasonable. I might just change the time base a little. There we go. But it doesn't look like we're clipping yet, so I'll increase the amplitude of the DDS. There we go. We've reached clipping there. So we're about 2.2 volt peak to peak input for change that to 2 volt per division, and we're still flat topping a little, so I'll drop that off even further. I'm going to ballpark that at 2 volt peak to peak input for 38.9 out. So we've got 38.9 volt out. Okay, so 38.9 divided by 2 equals that. The easiest way I found, not that I can see it, there it is to do that. And then we divide that by our load. Yeah, 47.2 watts roughly. Yeah, it's pretty close to the 50 watt ballpark. Yeah, those coils are getting red hot. Even the ones not actually doing anything. That's concerning for those coils to be red hot when it's not really even amplifying a signal there. I'm going to swap my input around and lose my ground lead. Okay, and I'm going to swap output connections. And we also have an output on that channel, reasonably nice, at roughly the same voltage, so it'll be the same wattage. Okay, and now I'll move to the subwoofer output, and at 1 kilohertz we're not going to see much, because 1 kilohertz is not a bass frequency. And indeed we can see hardly anything except some random noise. Until, of course, I change my frequency to say 60 hertz, and of course my time base is wrong, so we'll put that up to 5 milliseconds. There we go. We can see that it's a nice sinusoidal waveform, and it's not clipping, so I might up my amplitude. Yeah, it's still 2 volt peak to peak input for the full output power. So we're getting 42.6 volt peak to peak out on that channel. So at 42.6 volt, divide that by 2 to the power of 2 divided by the load. Yeah, it's lucky to output 56.7 watts. It's only about 9 watts higher than the 2 left and right channels. I also didn't have the sub bass volume all the way up when I was doing the power output test. So now with it at 68 hertz, because I entered the wrong number, and connected to the correct channel, of course. And then drop our time base down to 2 millicycles should do. Yeah, we're getting 44.5 now. So we do that calculation again, 44.5 divided by 2 to the power of 2 divided by 8 is 61 watts actually. Still impressive for a small little lamp. We are getting a little bit of flat bottoming here, but it's not going to have the output all the way up. And yes, the total volume also affects the sub bass volume. So anywho, so what we should do now is I'm going to swap back to the right channel, and we're going to do a sweep test on it just to have a look at our frequency response. And as we can see, it's starting to really roll off, and we're only at about 12 kilohertz. So the frequency response of the amplifier is, yeah, questionable. It's not the greatest frequency response I've ever seen. It starts rolling off about the 1 kilohertz mark. So the next thing to do would be to hook it up to a source of audio somehow, and some speakers, and see what it actually sounds like. Okay, I got a little 6 ohm TX 70 watt subwoofer, passive subwoofer, sitting on the floor here. I also bought that off of eBay, I'll just bring up the audio library and we'll turn the power on. Oh, there's a big thump there, but we know it works. So let's listen to some crap. Perfect. One of my leads popped off. Let me find a bit of track. I can't tell if that's distorting or not. It doesn't sound like it. But to me it sounds like it's lacking highs. Okay, it works, but it is lacking highs, which was pretty evident on the sweep test on the oscilloscope. Started rolling off around about the 1-2 kilohertz range, and it was a lot less output power at the 10 kilohertz range. So that would be the reason why it doesn't sound all that brilliant. So for what it is and how much it costs, yeah, it's okay. Is it hi-fi quality? Not really. I'm going to be brutally honest, and that thump is annoying, but I'm going to be brutally honest here that it's not the best amplifier I have ever tested. And in fact, it's not the best Class D amplifier I have ever tested. In fact, it's actually pretty crap, to be honest. It's got plenty of bass response, yes, but there's very little high-end response. And you really need a treble control there or something so you can get a little bit more highs out of it. But that is probably the design of the op-amp preamplifier circuitry here. They've deliberately limited the highs for some unknown reason. Who knows? There's no schematic for it, obviously. The other issue is how hot these coils, they're red hot to the touch. How hot these coils are getting even when the amplifier is sitting idle, doing nothing. even just connected to speakers or not even connected to any speakers. These are getting fairly hot. And so is this little heatsink. So for an amplifier that's just idling, doing nothing, it should not be generating that much heat. Class D in general should generate a lot less heat than Class AB and Class A counterparts. So in conclusion, it's a pretty simple amplifier for what it is. It does produce close to the power outputs claimed. And I only paid $13.06 for it. I just checked what my price was. That's Australian. They're worth about $9 or something US. Excuse me, they're not very expensive, but the guy that designed it, the Chinese dude that designed it, probably got paid his rice for the week for that, and the Chinese dude that assembled it also probably got paid his rice for the week. And yeah, you know, it is what it is. It's crap, I must admit, but it does work. So would I recommend this amplifier to anyone looking to maybe make a 2.1 speaker system for a computer? Yeah, you could, but just don't expect great highs out of it. You could delve in a little bit further into the electronics here and maybe modify some of the op-amp stages, but most of the resistors, in fact all the resistors, are surface mount, so yeah, good luck with that. Anyway, I'm going to end this video here, and I hope you enjoyed it. And if you did, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. There'll also be a link in the description to where I got this from. And as always, this is the Astro 30 saying, see ya, have a great day. The camera still works, I just dropped it. Looks like it still works. Yeah, it still works.